Let's talk about the essential parts of matrix operations, that's addition, subtraction, and multiplication of matrices. This segment will focus on matrix multiplication. So let's talk about matrix multiplication. First of all, it is only possible when the number of columns in the first matrix is equal to the number of rows in the second matrix. For example, multiplying a matrix A that's 3 rows and 4 columns by a matrix B that's 4 rows and 2 columns is possible. And in fact, it results in a 3 by 2 matrix. That's the number of rows in the first matrix times the number of columns in the second matrix. Multiplying a matrix A that's 3 rows and 4 columns by matrix B that's 3 rows and 2 columns is not possible because the number of columns in matrix A is not equal to the number of rows in matrix B. Okay, so fasten your seatbelts because matrix multiplication doesn't work in as straightforward a manner as matrix addition and subtraction. You're going to do this by multiplying across the first matrix and down the second matrix. You're using the rows of the first matrix, multiplying them by the columns of the second matrix. Each element in the row is multiplied by the next element in the column, and you proceed across the row and down the column, adding the total together. That total becomes that element of the new matrix, corresponding to where the row and the column intersect. Let's look at kind of the general example here, where we have a matrix P, which has elements P11, P12, P21, and P22, and another matrix Q, which has its own elements. And remember, the first number is the row, the second number is the column. So P22 is the second row, second column element in the P matrix. So if we want to multiply these two matrices P times Q, what we're going to do is we're going to proceed across the rows and down the columns, adding up our total as we go along. So to get the first element in the new multiplied matrix, we have to take P11 times Q11 plus P12 times Q21. Notice how we went across the row and down the column. P11 times Q11, P12 times Q21. The element where the row and the column intersect, which is the first element, the 1, 1 element, is going to be the sum of those multiplications. The element down here, element 2, 1, we're going to go across the second row and down the first column to intersect at element 2, 1. So to get this element 2, 1, we've got to take P21 times Q11 plus P22 times Q21. Again, we're going across the row, down the column. Add those together, we get element 2, 1 of the new matrix. To get the last element, 2, 2, we're going to multiply, again, the second row by the second column. So it's P21 times Q12 plus P22 times Q22. Add those up. The total of those two multiplications is element 2, 2 of the new matrix. So let's look at a tangible example now that you've looked at the theoretical example with P and Q. Let's have a matrix C that it's a 2 by 2 matrix with the following elements, 2, 3, negative 1, 5, and matrix D with 4, 7, 1, and negative 2. Since the number of columns in the first matrix equals the number of rows in the second matrix, we can multiply them. So C times D is going to equal this matrix times the second matrix. So let's go step by step. First element is going to be 2 times 4 plus 3 times 1. Next element is going to be 2 times 7 plus 3 times negative 2. Down to the bottom row, it's going to be negative 1 times 4 plus 5 times 1 and negative 1 times 7 plus 5 times negative 2. As with any matrix operation, you've got to be careful with your negatives, but when we add these elements up, we get 2 times 4 plus 3 times 1 is 11. This number turns out to be 8. This number 1, and negative 1 times 7 plus 5 times negative 2 is negative 17. So our final result of multiplying matrix C by matrix D is 11, 8, 1, negative 17. It is a 2 by 2 matrix. So that's how you multiply matrices, and it can only be done in certain circumstances where the number of columns in matrix 1 equals the number of rows in matrix 2. We'll look at real-world application of this in class.